Hi, my name is Nathan Carr and I am a final year software development student at ATU Galway, and this is my final year project. The project is called AI Phishing Email Detection with Explainable AI and MITRE ATT&CK mapping. So the basic idea is this: phishing emails are one of the most common ways people get hacked. You have probably seen them yourself. Emails pretending to be your bank or telling you your account is about to be closed. There are already AI systems out there that can detect these, but most of them just give you a yes or no answer without explaining why. That was the gap I wanted to fill. I wanted to build something that not only catches phishing emails but actually shows you the reasoning behind every decision it makes. So let me show you how the system was built. The first step is the data. I combined 4 publicly available email datasets, legitimate emails from the Enron corpus, and phishing examples from Spam Assassin, Nazario, and the Nigerian fraud collection. After cleaning and balancing them, I ended up with 21,402 emails, half legitimate and half phishing. Each email is processed using a technique called TF-IDF, which gives more weight to the words that appear in one specific email, but rarely across the whole dataset. So words like urgent or verify your account stand out as significant. A logistic regression classifier then learns which combination of words are associated with phishing versus legitimate email. Here are the results. 93.76 accuracy with balanced precision and recall across both classes. The ROC AUC score is 0.9808, which is strong. I also ran this through repeated cross-validation. 5 folds, 3 repeats, 15 evaluation runs in total, and the confidence interval for AUC was 0.978 to 0.982, which tells me the performance is genuinely consistent and this is not a lucky split. Now let me show you the finished product. This is the Streamlit dashboard I built. On the left you have the settings panel where you can choose between 2 models, logistic aggression and Navi-Bayes. Adjust the classification threshold and toggle between LIME and SHAP for explanations. In the main area, you paste in an email or upload a .eml file and hit Analyze Email. Let me load one of the built-in examples first. So, this is a classic phishing attempt. It is telling the user that their account is about to be suspended and asking them to click a link to resolve it. Let me analyze it. And you can see straight away it is classified as phishing with an 83.4% confidence. But more importantly, look at this section here. Why this classification? This is the explainability comes in. It is showing me that the words account, click, HTTP, and login were the biggest contributors to that decision. Those are all genuinely relevant phishing signals, which is exactly what you want to see. Over on the right, you have the MITRE ATT&CK mapping. It has categorized this email as T1566.002, which is a link-based phishing technique. That is useful because it connects the detection system to a real cybersecurity framework that security teams actually use in practice. And down here, the dashboard also explains what phishing and legitimate indicators look like in plain language, which makes the system accessible to someone who is not a machine learning expert. Now, let me try a legitimate email to show the other side. As here you can see, it is classified it as legitimate, with a low phishing probability. The explanation shows words that pushed it towards legitimate rather than phishing, which is exactly what you would expect for a plain business email like above. Now, the LIME explanation is great for individual emails, but I also wanted to understand what the model relies on globally across the dataset. This is where SHAP comes in. SHAP computed the average contribution of every word across 2,000 training emails, and this is one of the most interesting findings in the whole project. Look at the top features: Enron, etc., 2002, Linux. These are not phishing signals at all. They are just words that appear a lot in the Enron email corpus, which was used for the legitimate training data. What this tells me is that the model has partly learned to tell the difference between the two specific datasets rather than detecting phishing in a general sense. This is a finding that you would not spot from looking at the accuracy score alone. It is only visible because of the SHAP analysis, which is exactly why explainability matters in my project. Further down the list, you do see genuinely relevant signals: account, HTTP, click, bank. So the model is not entirely wrong, but the prominence of those dataset artifacts at the top is a real limitation that I discuss in detail in my dissertation. One of the things I was not happy with in standard phishing detection research is that most projects just test on a train test split. That tells you how the model performs on data it has never seen, but it does not tell you how it performs against someone who is actively trying to get around it. So I built an attacker simulation. I created 4 attack rules: adding urgency language, spoofing a bank security notice, spoofing a tax authority message, and injecting a fake URL. These were applied individually and in pairs, giving 16 different attack combinations and tested across 3 different classification thresholds. Look at the right side of the graph. Any rule chain that includes fake underscore link achieves 100% detection. Fake underscore link plus urgency, fake underscore link plus spoof underscore bank, spoof underscore bank plus fake underscore link, all 1.0. Any email with a suspicious URL in it, the model catches every single time. Now look at the other end. Spoof underscore revenue alone is down at just 16.7%. And even when you combine spoof underscore revenue with spoof underscore bank, you only achieve 0.5. The moment you add fake underscore link to any chain, though, detection shoots back up to 0.9. That tells you clearly that URL vocabulary is the model's strongest signal, and social engineering language without a link is where it struggles. And raising the threshold from 0.5 to 0.7 drops detection rate from 96.9% to 57.8%. Threshold choice is a critical decision in any real deployment. And this one shows that multi-rule attacks combining 2 techniques are actually easier to detect than single-rule attacks, which is counterintuitive. A more aggressive attacker who combines multiple techniques introduces more suspicious vocabulary, and the model picks up on it more easily. The last major component is the MITRE ATT&CK mapping. Rather than using this mapping as a labeling tool, I actually evaluated how accurate it is against a manually labeled validation set. Primary label accuracy came out at 93.3%, and the multi-label micro recall was 94.1%. 3 out of the 5 techniques achieved perfect F1 scores. The system rarely misses a technique that is actually present in an email, which in a security context is the most important direction to get right. Missing a threat is worse than over-flagging. So to wrap up, what I set out to build was a phishing detection system that explains itself, and I think that goal was achieved. The accuracy is strong at 93.76%, the cross-validation confirms it is stable, and the attacker simulation and SHAP analysis both surface specific weaknesses that standard metrics would never reveal. If I were to continue this, the main next steps would be testing a transformer model like BERT on the same pipeline, adding URL metadata analysis to tackle the social engineering vulnerability, and getting hold of a more modern datasets that includes LLM generated phishing emails, which is where the real threat is heading right now. The full code base is on my GitHub account and is fully reproducible. Thank you for watching.